Today we'll be talking about foaming slurries. Modern slurries more and more have organic components in them, which are typically polymers or surfactants, and these components can cause foaming if the slurry is not handled correctly. A lot of our new slurries have components in them that will generate foam when the slurry is splashed or air is entrained in it. These components are in there because they're absolutely necessary for the polishing process. We try and minimize it as much as possible, but due to the constraints and the requirements of today's modern CMP applications, they have to be in there. We take as much care as we possibly can to give the customer all the information they need to avoid any issues with foaming. However, if the distribution system isn't configured correctly, it can be a real problem. And I can show you a couple different ways. This is a surfactant similar to what you might find in one of our slurries. I'm going to put it in here, and then we're going to see how these two different types of dispense heads react. Foaming is a concern in slurry for three reasons. The first reason is the foam can pull organic components out of the slurry and retain them, so the materials are not present or not present at the correct concentration in the slurry when it's transferred into the distribution system. This can have an impact on your polishing process and cause variations or issues. The second reason that foaming is a big concern is the fact that the foam has a very large surface area and is prone to drying, especially in the dry conditions inside a fab. If the foam is allowed to dry out, it can entrain particles, it can entrain organics, polymers, and make a real mess. Basically, it can adhere to your dip tubes, your dispense heads, and those particles, once they start to build up, can flake off and get carried into the system and cause polishing defects. The third reason that foam is a concern has to do with the design of distribution systems. Many distribution systems use capacitive sensors, which are non-contact level sensors, in order to determine the liquid level inside drums and tanks in the system. If you have a foam present and it interacts with the capacitive sensor, you will not get an accurate reading on what your liquid level is inside a tank. And this can result in artificially high readings if the foam is present at the top of the tank, and it can set off over-level sensors or overflow sensors. At the bottom of the tank, you can run out of slurry and the foam is still present, and you could starve your system. Either one of these is to be avoided. If you look at this is a capacitive sensor that we've set up. When the light is out, there is no liquid present. And you can see as I move into the foam area, the light turns on, and we move into liquid, the light stays on. The problem is the light doesn't go off until we're approximately 1.5 inches above the actual liquid level in the container. So you can see, even at a relatively short drop of maybe 4 or 5 inches, we've already generated a pretty generous amount of foam. As the level in the tank drops, that fall height increases and the amount of foam goes up significantly. For that reason, we uniformly recommend that you use separate feed and return dispense heads and dip tubes for all foaming slurries. When we're in the commercialization process, we do a foaming evaluation study on new slurries to determine what level of foaming, if any, they might generate. When we're doing this, we try and characterize it as much as possible in looking at the level of foam that it generates and how persistent that foam is. So a persistent foam that is generated at a high level is really the worst case, and it's something that we take great pains to try and avoid if at all possible. If it is absolutely required by the formulation of the slurry, We will take great pains in pointing this out, the correct handling procedures for this material in the individual mixing and handling document.